So welcome back to lecture 2 of hyperbolic functions, and today we're going to be looking at equations that involve hyperbolic functions. But before you go on, I want you to go over lecture 1 thoroughly, understand the definitions of each of the hyperbolic functions because they are crucial when it comes to solving equations. So let's just get on with this lecture. I've always been saying this, and that is when you dealing with hyperbolic functions, it's always good to revisit the definitions. And you remember sin x is e to the x minus e to the minus x over 2. Cos x is e to the x plus e to the minus x over 2. These first two are probably the most important because you can derive everything else from there, like tangent is sine over cos. Cosec is 1 over sine, and so forth. So the first two are crucial, and don't mix up the signs. So that's basically what we're going to use for the rest of this lecture. Now, I'm not sure whether you actually prove this or not. Sine of x plus y is equal to sine x cos y plus cos x sine y. And this was the last lecture and left this as homework. You leave things as homework, we expect you to do it from first principles. You don't learn or read math, you do math. So let's just try this. So let's look at the right hand side here. What is the right hand side? The right hand side will tell me something like the product sin x cos y plus cos x sin y. If I just go to the definition, that's e to the x minus e to the minus x over 2. It's a nice use of the definition. That's a plus, correct? All over 2 plus e to the x plus e to the minus x over 2. And then you have e to the e to the y minus e to the minus y all over 2. Multiply that out, the 2 and 2, that's going to be quarter. That's going to be e to the x times e to the y is e to the x plus y, correct? Then the middle term there, and that's going to be minus e to the minus x plus y, right? Just remember we're multiplying, and then the outer term being that one, would be plus e to the x minus y, and finally these two over here. When I multiply, there's a minus sign, and you're going to get e to the minus x minus y all over 2 times 2 is 4. Now, if you look at this very carefully, let's look at the other one. So that's going to be plus e to the x, that'll be e to the x plus y plus e to the, I'm just going to do it very slowly, stuff that we learned in school. E to the x, be careful, there's a minus sign there. E to the x times that'll be e to the x minus y, and then finally there's another minus sign. E to the minus x minus y, 2 times 2 is 4. So let's just see whether things start to cancel out or they add up. And this is interesting. So if you look at e to the x plus y over 4 plus e to the x plus y over 4, that gives me e to the x plus y all over 2. Pause, take a breath, and check that out. E to the minus x plus y with a minus sign, and e to the minus x plus y with a plus sign, that's going to cancel out. Please check that. E to the x minus y, e to the x minus y, but with a minus sign, cancels out. Beautiful. So what have I got here? I've got e to the minus x minus y with a minus sign and minus. So that just becomes minus. Watch this, watch this, watch this. Beautiful, yeah. E to the minus x minus y all over 2. That looks very interesting. So 2 as a common factor over there. So surely I can write this as e to the x plus y minus e. Watch, there's a minus sign there. Minus, take that as a common factor. X plus y all over 2. Yes, same denominator. But what is that? That goes like e to the theta minus e to the minus theta all over 2. Sine of x plus y. And we just proved that the left-hand side is equal to the right-hand side. Brilliant. Love this question. Be wary of it in the exams. Okay, here's a question we discussed in class. Pretty straightforward. Identity again, cos 2x is cos squared x plus sine squared x. So what is the right-hand side? The right-hand side is nothing more than, let's just see, cos squared x plus sine squared x. Again, when I said go back to the definition, so that's e to the x plus e to the minus x over 2 all squared plus e to the x minus e to the minus x over 2 all squared. So open up those brackets. That's going to give you e to the 2x plus 2e to the x. Follow this. Plus e to the minus 2x all over 4 plus, let's see, that's e to the 2x minus 2e to the x times e to the minus x. That squared becomes plus e to the minus 2x. Again, all over 4. And notice the plus and then minus sign is going to go away. That and that becomes 2e to the 2x plus 2e to the minus 2x all over 4. And yeah, we expect this result, e to the minus 2x all over 2, which is nothing more than cos 2x. And there's your 1 mark. Awesome. All right, so remind you, this one I also had in the last lecture. Tangent of ln of x proved to be x squared minus 1 over x squared plus 1. Hint, work with the left-hand side. Left-hand side is tangent of ln x. But what is tangent? Tangent of ln x would be cos of ln x all over sine of ln x. Simplify and make sure you do this. Okay, so here's a typical equation, cos x equals 2. How do we do this? We want a value or values of x for which this function hits 2. So I said, as before, use the definition. So we have e to the x plus e to the minus x all over 2 equals 2. You must agree with me that this is e to the x plus e to the minus x equals 4, correct? And don't like that e to the minus x, so what do I do with that? All right, there's e to the x plus 1 over e to the x minus 4 equals to 0. Do you see what happens there? Don't blink, you'd miss it. And then multiply throughout by e to the x, and we're going to get e to the 2x, correct? Minus 4e to the x plus 1 equals 0. And then it's pretty straightforward after that. You know the usual story on what we did in grade 1. We let k equal to e to the x. What is k squared equal to? E to 2x. So this becomes k squared minus 4k plus 1 equals to 0. We know this is not going to factorize. Yeah, so we're going to use the formula. So I'm going to get out here, follow me. So I'm going to solve for k. So k is equal to minus b, which is 4, plus or minus b squared, which is 16, minus 4ac. Check my algebra, all over 2. So I'm going to get 4 plus or minus 16 minus 4 is, that's going to give me 12. Pretty straightforward, all over 2. But 12 is 4 times 3, the square root of 4. You use this in your calculator over there. So this becomes 2 plus or minus 4. There's root 3 like that. Check that with your calculator. But they didn't give us k in the exam. We are solving for x there. So we got e to the x equals to 2 plus root 3, or e to the x equals to 2 minus root 3. And how do we solve for x? We take ln on both sides and we are home. So x turns out to be ln of 2 plus root 3, or x is equal to ln of 2 minus root 3. Write neatly. You want to lay your work out properly. This is really bad. But I'm using this just to teach you, so follow this very carefully. Don't rush through it. Make sure you understand this before you move on to the next problem. All right, so let's just solve this one. Solve. Let's just cosh x minus sine x equals to 1. Is there a solution for this one? Well, again, let's appeal to the definition. What is that? Take that out, and then let's get to this one, and then cosh x is e to the x plus e to the minus. Be careful of the signs, minus, watch the bracket, e to the x minus e to the minus x all over 2 equals to 1. Open up the bracket, so we're going to have e to the x plus e to the minus x over 2 minus e to the x, right, over 2, watch this, plus e to the minus x over 2 minus 1 equals to 0. Should have opened up the bracket over here, but you can see straight away then that is going to cancel with that. And what is that? No. Minus and minus is a plus, bro. So e to the minus x and e to the minus x, that's so what I'm left with is e to the minus x over 2 plus e to the minus x over 2 minus 1 equals to 0. E to the minus x over 2 plus e to the minus x over 2 is just e to the minus x. So cool, so you get e to the minus x minus 1 equals to 0. And how do we solve for that? Well, that tells me that e to the minus x equals to 1. Take ln on both sides, see, like this, equals to ln of 1, really. So that becomes minus x ln e equals to 0. And the only possible solution here is x equals to 0. Let's just test that. Cosh of 0 is 1. Sine of 0 is 0. So 1 equals to 1. We should have spotted that right at the beginning. But it's a really cool, instructive way of actually looking at this equation. Cool stuff, man. Okay, let's try another one. This is sine 2x equals to 3 sine of x. Now be very careful. You got sine 2x equal to 3 sine x. You could split this up into exponentials, and you can do that, and I want you to, and you'll run into all sorts of weird things. But let's use the identity. So this tells me that 2 sine x cosh x minus 3 sine x equals to 0. So don't divide both sides by sine x. If you do that, then you're assuming that sine x is not 0. Now take out sine x as a common factor. So then we're going to get 2 cosh x minus 1 equals to 0. And then we want to solve sine x equal to 0, or 2 cosh x minus 1 equals to 0. Got that? That's pretty straightforward. Sine x equal to 0, we know that x is 0. You can check that out. So this one tells me that x is equal to 0. This one, you got cosh x equals to a half. Beautiful. E to the plus e to the minus x over 2 equals to that. Knock out the 2's, and we're going to get e to the x plus e to the minus x equals to 1. And then if you multiply throughout by e to the x, we're going to get e to the 2x plus 1 equals to e to the x. Please check that. And then that just becomes the quadratic, e to the 2x minus e to the x plus 1 equals to 0. We're going to let k let k equal to e to the x, and then we got k squared minus k plus 1 equals to 0. And this is now getting a bit boring for me. I'm actually falling asleep. We use the quadratic formula. Bang! We solve for k. Once we got k, let that equal to e to the x. So let's just see what k is. K is minus b plus or minus the square root of b squared, which is 1 minus 4ac all over 2. Hey, what's really happening over here? Did me make a mistake? So let's just have a look. So 2 cosh x, that's going to be a half. That's e to the x. Then we can bang. That becomes that. That's e to the 2x plus 1 is equal to e to the x. and then you bring that onto the other side. So you're going to get e to the 2x minus e to the x plus 1 equals to 0. And k minus b plus or minus the square root of b squared minus 4ac all over 2. What seems to be the issue here is very simple, and I made a mistake right over here. That is the problem. That's the reason why we have to write neatly all the time. Write neatly. Legible. So I took that 3 as a 1, and bang, what a disaster. So here, this is wrong because of me writing. Let's redo this question from scratch. Okay, so let's start again. Sine 2x equals to 3 sine x. This is 2 sine x cos x minus 3 sine x equals to 0. Takes sine x as a common factor, so we're going to get 2 cos x minus 3 equals to 0. So this is pretty straightforward. Sine x equals to 0. 2 cos x minus 3 equals to 0. So this tells me that cos x here is equal to 3 over 2. This tells me here x is 0, right? Split that screen. So now solving cos x equal to 3 over 2, pretty straightforward. E to the x plus e to the minus x all over 2 must equal to 3 over 2. Let's get rid of these 2's here. So we're going to get e to the x plus e to the minus x minus 3 equals to 0. Multiply throughout by e to the x. And that tells me that e to the power 2x minus 3e to the x plus 1 equals to 0. Ain't going to factorize here. So we can use, well, k equal to e to the x. Just remind you, k squared minus 3k plus 1 equals to 0. What is k equal to? Minus b plus or minus b squared is 9 minus 4ac all over 2. So it's 3 plus or minus the square root of 5 all over 2. K is equal to 3 plus or minus root 5 all over 2. And eventually what we got then is e to the x is equal to 3 plus root 5 all over 2, or e to the x is equal to 3 minus root 5 all over 2. Take lens on both sides and check this out. I've got x equals to plus or minus 0,9624, and not forgetting x equals to 0. 3 roots here. 3 roots, 2x, x. Awesome. Here's your 1 mark. Okay, so homework. Of course, homework. So solve for x here. So the first one is 20 cos x. 20 cos x plus 7 sin x equals 24. Please check the answer. You got 2 possible solutions. Remember, it's a quadratic, 0.3677, or x equals minus 1.0999. That's 9. Okay, that's the first one. Okay, here's one of my favorite ones, so please pay careful attention to this one. Cos 2x plus sin squared x minus 5 cos x plus 6 equals to 0. So solve for x. I got cos 2x plus sin squared x minus 5 cos x plus 6 equals to 0. That should do the trick quite nicely. Just have a look at that. There's an x missing over there. So cos 2x plus sin squared x minus 5 cos x plus 6 equals to 0. Solve for x. Pay careful attention. I like this question. Okay, so yeah, we at the end of this section, but just thought of a question and I want you to actually solve for this one. I got cosh 2 theta equals e to the power 10. Find theta. All right, so this brings to an end our excursion into hyperbolic functions for now, because later on when we look at the calculus, we're going to look at derivatives, and then later on still we're going to be looking at the inverse of these hyperbolic functions. So hold on to your seats, and it's going to be a really exciting journey ahead. So please work through these because they're going to be part of your exams. Make sure you understand them carefully. And like I said, do the problems. Don't read, do mathematics. See you on the other side of 11, whatever that means.